All right. In this tutorial, I'm going to show you how to do those metric stuff with the Python program. It's seriously very fast here, and it will help you to understand. In case you know everything is done with software these days, and you have to understand the concept and the syntax behind how to do the same thing with Python and then get the same results. Because if the matrix is up to maybe 4 by 4, 5 by 5, it's a whole lot of waste of time if you start to develop all those things or want to develop all those things with time. All right. So without wasting much time, the first thing you do, I've opened my browser already. I've loaded my, I want to use Jupyter Notebook. All right. You don't know about Jupyter Notebook. It's very good, man. You have to learn about that one, but this tutorial is not for that though. So you click on the title so that you can give it the title so you can run the program very well. All right, save, give a title of what you want to do, how you want to save your notebook. So I want to save it metrics, eigenvalues, metrics, eigen underscore values, uh, and underscore vector, vectors, eigenvalues, and vectors. All right, I've saved that so it reflected on the taskbar there. So the next thing I want to do before we can do those things is we going to import the module we'll be using for this. I will import, oh, NumPy is enough for this, but we'll just pandas also just to make my import to make sense. Import NumPy as as the NP. Import another function there, import uh, pandas, sorry, pandas as PD. I don't need much. I'm not going to do edit annotation. All right, shift enter. All right, that has run already. So next thing I'll be looking for is the array. I want to write my metrics that I want to use right now. I'll say A is assign equals to numpy function dot array. Then you create the array. The array is the method. Yes. So you put the first row 4, 1. You close it. You put a comma, and you enter the second row. That is 2, 3. That is the matrix we're using that time. All right. So you close it 2 times so that, all right, then you close the parentheses. That one is finished. Now, next thing there is you type the eigenvalues. Okay. Eigenvalues command and eigenvectors. Eigenvectors. All right, let's put it there. All right, you put that equals to the numpy functionality again. And then you use this module or function, a linear or dot e I G standing for eigens of the vector matrix A. All right. The eigens, like it provides the eigens of both the eigenvectors and the eigenvalues. All right. This is enough. All right. So the next thing there is, I would like us to print this out so that you see. So we print the eigenvalues. Let me make it neat. The eigen values, the eigenvalues. All right, eigenvalues are Can do something like column here. Then we close the string. Then comma is gonna be eigenvalue. This thing we type here. Yeah, take this Control C and then you place it here, Control V. Then you're going to do the same thing again for the eigenvectors because the print function should be in the next line. You say eigen vector vectors are yours. You place that stuff again and you close. So the open is going to be the eigenvectors that you wrote here. While I like picking it up, I don't want to make mistake in my Control C and drop it here, Control V. All right, and close it. It's finished. So you can Shift Enter. It has provided eigenvalues and the eigen, of course, vowel. Let's see what is wrong there. Print. Sorry. I'm using a capital letter to do the print function in the second row. So it's not supposed to be not compatible. It's becoming a variable there. So sorry, it's not supposed to be like that. Print is like this. All right, so let's run that again. Enter. All right, so we got that. You have the eigenvalues and you have the eigenvalue of the vectors. So if you check our previous videos, we have something similar to this. So you may want to ask, why is this one's like this? Yeah, the eigenvectors I'm talking about precisely is because it has been initial value or the matrix value that the module is using, it has gone deep far in doing the modeling to get the actual values than you want to or can do with hand. So this one is highly proper. So the eigenvalues are still 5 and 2. Okay, all right. So let me say I want to uh, I want to create an inverse of the matrix using this eigenvalue and eigenvectors. So the only thing I need is supposed to be the numpy. So let me say to get uh, to to uh, get the inverse inverse of a matrix. You will really like it. Matrix using using Python, 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 in Python. All right. I was just trying to make it separate from that side. It all is gonna work together. So good. All right. So let's go again. The first thing I would find my matrix. I've defined the matrix already here. I've defined the matrix already here. So let me just copy that and bring down for clarity. In case you want to do that, Control C. I'll bring it down here. I will say I'm going to define my matrix. Define matrix. All right. For defining matrix, we look at it here. All right, I'm done that already. So the next thing that I want to do here is to calculate the eigenvalues. We've done that already in the previous video, previous example. So I'm going to copy this. Let me just be putting the contents, the comments. So the next thing is to calculate, to calculate, to calculate the eigen values and eigen vectors, okay, of this matrix, this matrix. All right. So to do that, I'm just going to copy this again. Going to copy that because this is what calculate those stuff. Control C, bring it down here, and Control V. All right. So the next thing I want to get here is the to form a diagonal matrix D, I didn't really explain the theory behind this. We're supposed to get the diagonal matrix, we call that D, and the matrix of the eigenvectors P. So to let me put it there, you get the diagonal matrix, get the excuse me, let me power my system. No, all right. So like I said, you get the diagonal matrix. All right, get the diagonal matrix for the diagonal matrix. We call that D, and on the on the eigenvectors matrix P, diagonal matrix D, and the matrix of the eigenvectors. Okay, and the matrix of the eigenvectors. Okay, and vectors are vectors P. Okay, to do that, we follow the algorithm here. So I'm going to write D is equals to, so NP, everything here is numpy. So if you don't understand numpy, you really have to get that. So dig stands for the diagonal. So that is defined by 1 slash, okay, that's divided by the eigenvalues. So the eigen, if you don't want to make the mistake, you come here, you copy your eigenvalues that you wrote earlier. Okay, copy that. Oh, your eigenvalues. Okay, Control C and paste there. Okay, Control V. All right, let me go down, correct that. I think I revised this thing there. Don't make any mistake. Control V. Okay, then eigenvalues. So you close that. So that is the definition. And you also get for the P is equals to another eigenvectors. So we've got the eigenvectors already. So you just write eigenvectors. So I'm going to start here and get my eigenvector definition that I use. Control C and drop it here. Of the eigenvectors. Okay. All right. Let's make it neat. All right. Okay. So what next? The next thing we want to get is to calculate the inverse of D. So you calculate the inverse of the D, of the D, the inverse of the D. So, so to calculate the inverse, let's call that D underscore INV. So that equals, inverse equals to, is still going to be numpy. NP, the diagonal of 1 slash a oh, that is what I use for, no. Please, I'm going to take this out from here. This is not supposed to be here. So this is, copy this value is not for here. Control C and place it here. This is where it belongs, Control V. So we, one all over is for the inverse of the D. So that is the inverse of that. Okay. So 1 over the eigenvalues. So the other one's supposed to be the diagonal of the eigenvalues only. So remove the 1 over from here. Very sorry about that. Okay, so that's that for the inverse of it. Okay, so the next thing is to calculate the inverse of A as P times D inverse times P inverse. Okay, so next thing is to calculate the inverse, 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 uh, inverse of A. Okay, as from the theorem perspective, that equals to P times uh, D inverse, D underscore inverse, then times uh, what else the P inverse, P uh, P inverse, P inverse. Okay, okay. So that is going to be equals to A inverse A underscore INV equals to the P, all right, the capital P. I'm going to use the art sign. I think this is art. Oh no, this is art. No. Okay, this is my art sign. Then D inverse. I'm just going to come here, copy the D inverse, Control C, and drop it here. Okay, Control V, and then I bring my art sign again, Control that. Then I'm going to do NP, the inverse of P, because I did not define it there. NP, please give it a little space. Give it a little space. Give it a little space. Uh, okay, okay. It shouldn't be very so tight so that you see what I'm doing. All right. So the next thing is that NP dot that our function linear. Okay. Linear. Okay. Dot. Oh, the INV, that's the inverse of the P that we did not got the first time, so I'll drop P there and drop it there. So I'll press enter. That is done. So the next thing is to print that the inverse of A, just put a little star there. The inverse of A, inverse of A, inverse of the matrix A is, okay, um, close that in, and then that is going to be equals to, um, equals to, comma, okay, that is going to be equals to, uh, A inverse. Okay, I've gotten that already. That should be equal to A underscore I in V. It's too close because you've gotten everything. So this will shift enter. Oh wow. Let's see. All right. So that is how to get that. You can see that the matrix obtained there is you have the matrix obtained there is exactly what we expect. Exactly what we expect. Look at it there. You have yeah, 0, 3, yeah, 0 0.3, and minus 0 0.1, and 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 0 0.2 and 0 0.4. Okay, let's go to the board and check if that's true. So if we you know go to the um okay. Well, assuming we this is where we are. Just drop that in. For now, let's go check if that answer is truly what it is. Okay. Now we have the matrix. The matrix is 4 and 1 and 2 and 3. Remember the inverse is supposed to be the interchange position. We find the determinant. The determinant of this matrix is going to be equals to 12 minus 2. So 12 minus 2, and that is equals to 10. Okay, it's equals to 10. So, and the inverse of this matrix supposed to be equals to the inverse of this matrix supposed to be equals to A inverse. It change the position, swap minus in the other diagonal. So it will be, excuse me, that will be by hand supposed to be equals to 1 over the determinant, which is 10, into, we have 3, we have minus 2, minus 1, we have minus 2, we have minus 1, then you change the position of 3, we swap that position. Okay, because these are the cofactor matrices position. All right, so allowing that to enter into the constant that to enter into the matrix, then this becomes 3 over 10 minus 1 over 10 minus 2 over 10 and then 4 over 10. If you evaluate this out, this should give us, this is 0.3, this is minus 0.1, okay, and then this is minus 0.2, and lastly, this is 0.4. Of course, you can see that is exactly what we have here. This is 0.3, 0.1. We have 0 minus 0.2 and 0.4. It corresponds to the inverse we've gotten here. In fact, most of the time, if I realize if you want to deal with plenty of the other metrics, when the other metric is more than 3, it's more than 3 by 3, and you want to do it such that you you see the result as soon as possible. I prefer you use a Python language like this to run it through. It gives you all the stuff you need. It can even provide you with the eigenvalues and the eigenvectors. And I believe it will make you feel relief of all the stress that you would have maybe passing through using other stuff. I advise you to go learn a little programming to help in your research. Thank you very much. I believe this lesson really helped in some ways, and it makes sense if you will subscribe to the channel and like and comment where possible. All right. Thank you, and have a nice day.